There is an atom inside you right now that is keeping you alive. Billions of them, actually. Without them, you'd be dead within minutes. Your blood would stop carrying oxygen, your cells would suffocate, and it would all be over very quickly. And yet that exact same atom, in slightly the wrong amount, in slightly the wrong place, can start helping to build the very molecules that damage you from the inside. The ones scientists link to aging, to heart disease, to the slow breakdown of your own brain. Same atom, essential and dangerous. It's iron, and almost everything you've been told about it is only half the story. Let's be fair to iron first, because it has earned it. Right now, roughly 70% of the iron in your body is doing one heroic job, sitting inside your red blood cells, grabbing oxygen from your lungs, and carrying it to every corner of you. Every breath you take is only useful because iron is there to catch it, and when people don't have enough, they feel it. Iron deficiency is the single most common nutritional deficiency on the planet. It drags people into exhaustion, breathlessness, brain fog, a kind of gray flatness, and it hits menstruating women especially hard. So no, this is not a video telling you iron is bad, not even close. Here's what makes iron special, and it's the exact same thing that makes it dangerous. Iron is brilliant at passing electrons back and forth. It can hold an extra electron, let it go, then grab it again, flipping between two states over and over. That electron juggling is why it can carry oxygen. But your body is a warm, wet place, full of oxygen, and simply running your cells throws off a steady trickle of a byproduct called hydrogen peroxide. Normally harmless, your body mops it up, unless it meets a loose iron atom. Because when free iron and hydrogen peroxide come together, they react. It's called the Fenton reaction, and the thing it produces is genuinely nasty. It's called the hydroxyl radical, and it is essentially the most destructive free radical in all of biology. This thing does not wait around. It rips into whatever is nearest, the fatty membranes of your cells, your proteins, even the DNA in your genes, snatching electrons, breaking bonds, setting off chain reactions of damage. And here's the cruel part. The iron isn't used up. It gets its electron handed back and goes right back to making more. One iron atom can start fire after fire after fire. That's the double edge. The same electron trick that lets iron carry the oxygen you need is exactly what lets it strike the match. Which is why your body is, frankly, a little afraid of its own iron. It almost never lets iron drift around loose. The moment iron isn't being used, your body locks it away inside a protein called ferritin. Think of it as a microscopic safe. Iron goes in, the door shuts, and inside that safe it's held perfectly still, kept from reacting, kept from starting fires. As long as the safe has room, you're fine. The danger begins when there's more iron coming in than the safe can hold. So the real question becomes, what happens when iron keeps coming in and can't get out? And this is the part that genuinely surprised me when I first learned it. Your body has no way to get rid of excess iron. None. There's no off switch, no drain, no system that says, we've got too much, let's flush some. You can sweat out water. You can breathe off carbon dioxide. Your kidneys clear all sorts of things. But iron, once it's in, it's basically stuck. You lose a tiny amount, maybe a milligram a day, from shedding old skin and gut cells. That's it. The only real way your body offloads a meaningful amount of iron is by bleeding, which quietly splits the human race in two. If you menstruate, you offload a chunk of iron every single month. For decades, it keeps resetting the tank. But if you don't, if you're a man or a woman past menopause, that monthly release simply isn't happening. And since iron can't leave on its own, it does the only thing left to it. It accumulates, slowly, year after year. Back in 1981, a researcher named Jerome Sullivan looked at this and asked an uncomfortable question. Why do men get heart disease years earlier than women? And why does a woman's risk climb sharply after menopause, right around the time she stops losing iron every month? Maybe, he suggested, part of the answer was iron itself. Decades of it, building up, quietly oxidizing. Now, to be clear, that idea, the iron hypothesis, is still exactly that, a hypothesis. The studies are mixed, and the debate isn't settled. But it's a striking way to look at a pattern everyone else had explained differently. And if you want to see what too much iron actually does, there's a natural experiment walking among us. Some people are born with a genetic quirk, most often in a gene called HFE, that breaks the body's control over iron absorption. Their gut just keeps letting iron in, far more than they need, with no breaks. The condition is called hereditary hemochromatosis, and it is not rare. Plenty of people have it and have no idea. Over the years, all that unstoppable iron floods the organs. It scars the liver. It disturbs the heart's rhythm. It damages the pancreas so reliably that one old name for the disease was bronze diabetes, because the skin itself can turn a bronzed gray. This is iron overload made visible. And here's the detail I find almost poetic. The standard treatment isn't some cutting-edge drug, it's bloodletting. You remove blood, the body is forced to pull iron out of storage to rebuild it, and the levels come down. A single bag of donated blood carries off around 200 milligrams of iron. The oldest medicine there is, and for this, it works. So where does that leave the carnivore crowd, or honestly, anyone eating a lot of red meat? Let's be fair, because this gets oversimplified in both directions. Meat contains a form of iron called heme iron, and it's absorbed far more easily than the iron in plants, and it slips past some of the body's usual controls. On paper, that sounds alarming for a meat-heavy diet. But here's the honest truth. In a healthy person without those overload genes, the body still adapts. It dials absorption down as stores fill up, and high meat intake alone usually does not tip someone into dangerous overload. So this is not meat is poison. It really isn't. What's fair to say is subtler. You can't easily offload extra iron. Your stores tend to creep up with age no matter what. A real slice of people are quietly absorbing too much and don't know it. And some of the concerns around heme iron may come not from stored iron at all, but from oxidation happening right there in your gut as you digest. None of that means stop. It means one simple thing. Don't assume. Find out. And this is where it connects to something bigger than your heart. As we age, iron doesn't just build up in our organs, it builds up in our brains, in exactly the regions that falter in diseases like Alzheimer's and Parkinson's. Scientists have even named a form of cell death driven by iron and the runaway oxidation of cell membranes. They call it ferroptosis, literally iron death. And that same ferritin safe we talked about turns up sitting inside the plaques of the Alzheimer's brain. Now, I want to be careful here. No one has proven that stored iron causes these diseases. The iron building up might be a passenger as much as a driver. This is a frontier, not a verdict. But it has genuinely reframed how researchers think about a metal we used to assume was totally inert once it was tucked away. Stored iron, it turns out, may not be sitting there quite as harmlessly as we thought. So what do you actually do with all of this? And please take this as information, not instruction. Iron might be the one nutrient where the smart move isn't to maximize, it's to measure. And measuring it well means more than a single number. A proper look at your iron includes how much you've got in storage, how saturated your iron transport system is, and how much is circulating in your blood, because any one of those on its own can mislead you. A high reading, for instance, can also just mean inflammation, not overload, which is exactly why you don't panic over one figure, and why this is a conversation with a doctor, not a self-diagnosis. And remember, normal on a lab report is just a population average. It's a floor to clear, not a target to chase. If you're curious how much iron you're actually taking in, especially from meat, a tool like Chronometer will show you, alongside 80+ other nutrients. Just keep the twist in mind. Unlike almost everything else you might track, once you've cleared the floor with iron, more is not the goal. And if your levels do come back genuinely high, the fix is almost anticlimactically simple, the very same one they use for hemochromatosis. You give blood, it draws your iron down, and it may save a stranger's life at the same time. But whether you actually need to is a medical decision, not a biohack to chase. And if you're on the other edge, deficient, running on empty, which is incredibly common if you menstruate, that matters just as much. Both edges of this blade are real. The goal was never more iron or less iron. It was the right iron for you. So here's the upgrade. Iron was never simply good, and it was never simply bad. It's the same atom either way, the one that carries your every breath, and the one that, in excess, can quietly turn against you. Essential and dangerous, decided almost entirely by dose. The people who really understand that don't fear iron, and they don't chase it. They just find out where they stand on the blade. If this changed how you think about that word on the side of your cereal box, save it somewhere. And if you want the deep dive on how to actually read an iron panel or on ferroptosis and aging, tell me in the comments. I'm working through these one atom at a time.